Hello student, in the last lecture we have seen that the chapter continuity or also it is complete. Now we will take next chapter, chapter number 9th, that is differentiations. Actually in this differentiation, actually it is the process of finding the derivative. It is called as differentiation. So first of all, definition of derivative. So here, if x and x plus delta x belongs to the domain of f, domain of function f, and the limit of function f of x plus delta x minus f of x divided by delta x, limit as delta x tends to 0, if this limit is exist, then the function f is said to be differentiable or derivable at x, and its limit is called as derivative of function f at x, and is denoted by f dash x or derivative of f x with respect to x, and so therefore it gives f dash x is equal to limit of function f of x plus delta x minus f of x whole divided by delta x, where limit as delta x tends to 0. And so this is the definition of the derivative. So here, if x and x plus delta x belongs to the domain of the function f, and if this limit of function f of x plus delta x minus f of x divided by delta x, limit as delta x tends to 0, if this limit is exist, then this function or this limit, the value of this limit is called as the derivative of the function f at x, and it is denoted by f dash x or derivative of fx divided with respect to x here, and the function is said to be derivable. If this limit is exist, then the function f is said to be derivable or differentiable function if this limit. So the value of this limit is called as the derivative of that function at x, and which is denoted by f dash x is equal to limit of f of x plus delta x minus f of x upon delta x, where limit as delta x tends to 0. We have already studied the limit chapter. So then we take a remark here. A remark first. So it is convenient to to take the letter H to denote increment delta x. So we may write this. So we denote the letter H to this increment delta x here. Delta x is here. Delta x is the small increment in x. That's why we denote this increment delta x by H here. So therefore f dash x equal to limit of f of x plus h here minus fx divided by h, limit as it tends to 0. And so this is the definition of the derivative. Now in the second remarks here, say the process of finding the derivative. Yes, the process of finding the derivative of the function, derivative of the function is called as a differentiation. Yes, डेरिवेटिव निकालने की, एखादे फंक्शन का डेरिवेटिव निकालने की जो प्रोसेस है उसे डिफरेंशिएशन कहते हैं. ओके, देन वी विल टेक नेक्स्ट आर्टिकल, Leibniz notation of derivative. Now Leibniz notation of derivative. Let y equal to f of x be a function and there be a small increment delta x in x corresponding to the increment delta y in y respectively. Then so therefore delta y is the small increment in y and delta x is a small increment in x. So therefore we write this y plus delta y is equal to f of x plus delta x. And so take this y in this side here, in the right hand side. So delta y is equal to f of x plus delta x minus y. But here this y is nothing but f of x. F of x plus delta x minus delta, it is a f of x. Y is f of x, since y equal to f of x be a function. So therefore as here, as delta x is a small increment and delta x is non-zero, it is a small increment. So dividing throughout by delta x. So therefore it gives delta y upon delta x is equal to function f of x plus delta x minus f of x divided by delta x. So we have to divide throughout by delta x, because delta x is a small increment in x. So therefore now we are taking limit as delta x tends to 0, taking limit as delta x tends to 0 on both sides. So we get limit as delta y upon delta x as delta x tends to 0. It gives limit as delta x tends to 0 function f of x plus delta x minus f of x or fx divided by delta x. Or if this limit is exist, then the limiting value is called as a derivative of the function, and which is represented by dy by dx. If the above limit is exist, and limiting value is called as derivative of the function, and is denoted by, or can be represented by, dy by dx. And so therefore, or f dash x, and therefore if this limit y equal to f of x is a differential function of x, then we write this limit of delta y upon delta x tends to 0 is equal to dy by dx. And so therefore it is f dash x is equal to limit of f of x plus delta x minus f of x upon delta x, limit as delta x tends to 0, and this is called as Leibniz notation of derivative. So note here, if y equal to f of x be a differentiable function, of x, then this limit of delta y upon delta x, limit as delta x tends to 0, it gives dy by dx, means derivative of y with respect to x. And so therefore, and this also here, this limit of f of x plus delta x minus f of x upon delta x, limit as delta x tends to 0 is equal to also f dash x here. So f dash x means it is dy by dx, derivative of y with respect to x here. And so this is the Leibniz notation for derivative. So we will take a derivative of a right hand derivative. Now the right hand derivative, if y equal to f of x be a function, be a real valued function, and a be any real number, then limit of f of a plus h minus f of a upon h, limit as h tends to 0, is called right hand derivative. Right hand derivative of function f at x equal to a here, and is denoted by right hand derivative of f dash a of function f at x equal to a, or it is also denoted by f dash a plus. Similarly, we take left hand derivative. Left hand derivative if y equal to function f of x be a real valued function and a be any real number, then the limit of function f of a plus h minus f of a divided by h, limit as h tends to 0. Here it is right hand limit, write down here 0 plus, and here it is left hand, write down here 0 minus, is called left hand limit. Left hand derivative of function f at x equal to a and is denoted by left hand derivative of function f with respect to at a x equal to a, or which is also write f dash a minus. So this is the right hand derivative, h tends to 0 interval here, 0 plus, and here in the left hand derivative the interval is h tends to 0 minus. Whenever it is 0, h tends to 0, it is called as a 0 plus, it is called as a right hand derivative, and whenever interval of this limit is h tends to 0 minus, then this derivative is called as a left hand derivative. Write down a note here. Note: if a right hand derivative is equal to left hand derivative, then f dash a is exist. Derivative of that point f dash a is exist, and we say that the function is differentiable at x equal to a, and we say that f is differentiable at x equal to a, and if this right hand derivative is not equal to left hand derivative of a, then f dash a does not exist does not exist, and we say that function f is not differentiable, not differentiable at x equal to e. The same way, in continuity, if right hand limit is equal to left hand limit of that function, then we say that the limit is function is continuous at x equal to e. In the same way, if right hand derivative of that function equal to left hand derivative of that function, then we say that the function is differentiable at x equal to e. If right hand derivative is not equal to left hand derivative of that function, then we say that this function does not exist, means the function is not differentiable at x equal to e here. Now we will take next article. Next article, derivative by method of first principle. Derivative by first principle, method of first principle. First principle method. Find suppose our question is like this, find the derivative of the given function by using the first principle method. Yes, actually the first principle, finding the derivative of first principle method means, so we have to find the derivative by using the definition, or yes, definition of the derivative. So by using to finding the derivative by using the definition of the derivative, finding the derivative of function, finding the derivative of the function by using the definition of derivative. Finding the derivative of the function by using the definition of derivative. That is by using this formula or this method, this formula. It is the definition of that. F dash x, limit as x tends to 0 or h tends to 0, f of x plus h minus f of x upon h. So this formula, when we find the derivative of any function by using this formula, means it is actually the definition of the derivative. By using the definition of the derivative is called as the derivative by method of first principle, is referred as derivative of function from the first principle. From the first principle. Don't write here CIPAL, principal, PRINCIPL, yes. So this is the derivative by method by first principle method. Now we will take next article, derivative of some standard functions. Derivative of some standard functions. Okay, the first function, constant function. Constant function, that is a derivative of k with respect to x is equal to 0, where k is constant. And k belongs to any real number. K is any real number. It is a natural number or real number. K is constant. Therefore, so we use the first principle method, or we use the definition of the derivative to finding the derivative of that constant k. Let this function f of x equal to k here. Consider the given function f of x equal to k. K is a constant function. Then we write here, where there is x, we write here x plus h equal to, here x is absent, that side is k only. And now by first principle method. So first principle is definition, f dash x equal to limit of function f of x plus h minus function f of x upon h, limit as h tends to 0. So here finding the derivative of that function means actually we have to find the limit of that function. That's the limiting value is called as the derivative of that function. Right? So therefore, put here the value of f of x plus h. The value of f of x plus is k. Limit as h tends to 0. It is k, and also f of x, the value of f of x is k upon h. K minus k, it is 0 upon h, and therefore 0 upon anything it is 0. So therefore it is 0. Our limit, it is 0. Write directly here, limit of 0, it is 0. It is 0. Therefore f dash x equal to 0, and therefore derivative, it is also right in this way, derivative of our function f of x means k. F of x is here k. Derivative of k with respect to x is equal to 0. Hence, derivative of any function, k is any real number. For example, here we consider, suppose, for example, we consider the constant function 3 here. Consider the function 3. Yes, then its derivative also is 0. Its derivative f dash x is equal to 0 by using this formula here. 3 minus 3, it is 0. Any function. We consider also function f of x equal to a is a constant, b, etc. Its derivative is 0. So next standard function, power function. So derivative of power function. So power function is denoted by x raised to n, suppose. X raised to n in general. So its derivative is here n into x raised to n minus 1. Means power into x raised to power minus 1. And where n belongs to capital N, means n is any natural number. So consider, let our function f of x equal to x raised to n. Yes. Then we write, where there is x, we write x plus h. In the right hand side also x plus h raised to n here. Okay, then by first principle. So f dash x is equal to limit as h tends to 0 function f of x plus h minus f of x upon h. Put the value, substitute the value of f of x plus h and f of x here. So therefore f of x plus h, limit as h tends to 0, the value of f of x plus h is here x plus h raised to n minus the value of f of x is x raised to n upon h here, and so therefore it is equal to limit as s tends to 0. Actually we use here binomial expansion here. So by using binomial theorem, so we write this x raised to n plus then nc1 n combination of 1 into x raised to n minus 1 into h, this term, then plus third term n combination of 2 into x raised to n minus 2 third term into h square here, and plus so on, plus h raised to n here. Here in binomial expansion, first term is x raised to n and in the last term h raised to n. So middle second term is here n combination of 1 into x raised to n minus 1. Next term, first term is x raised to n, second x raised to n minus 1, means here the power of x is decreasing. In the last here, power of x is here x raised to n minus n, and n minus n it is 0, so x raised to 0 is 1, and also here n combination of, in the last, n combination of 1, n combination of 2, so on to n combination of n, and its value is 1. That's why here we no need to write n combination of n, its value is 1, x raised to 0, its value is 1. That's why it is only h raised to n. The power of h is increasing and the power of x is decreasing, minus this x raised to n as it is here. So this is the expansion of binomial expansion of, by using binomial expansion of here x plus h raised to n, its expansion, divided by whole divided by h here. Now we write in this side. So therefore f dash x equal to limit as h tends to 0. Here we cancel out these two terms here, x raised to n and minus x raised to n. Yes, we write here. So plus x raised to n and minus x raised to n. Now the remaining terms. From the remaining terms we take common h. So here h into, first term is n combination of 1 into x raised to n minus 1 into h. Then second term n combination of 2 x raised to n minus 2 into h square. We take h common, that's why. So here no need to write h, here write h into h here because h square here. So plus so on to plus here it is h raised to n minus 1 because we take common h raised to h common from this h raised to n. That's why it remains h raised to n minus 1 terms. When we add here h into h, there its power is 1. So plus 1 minus 1 will get cancelled. It remains h raised to n. And so therefore divided by h here. And so this h will get cancelled, and therefore apply limit remaining terms, limit as h tends to 0. So n combination 1 x raised to n minus 1 plus n combination 2 x raised to n minus 2 into h plus so on to plus h raised to n minus 1. Now the apply limit each and every terms. So it becomes 0. The second term is 0 because h is here, third term is so on to, this last term is also 0, but the first term is never 0 because there h is absent there. So that's why. So when we apply limit, so it is only n combination of 1 into x raised to n minus 1 plus 0 plus so on to plus 0. and so therefore it is only n combination of 1 to x raised to n minus 1. So it is f dash x. Now we find the value of this n combination of 1 by using the combination here, NCR. Formula for NCR, n combination of r. It is n factorial divided by r factorial or n minus r into r factorial. So this is formula. N means n here, no doubt. So our term NC1 here. Instead of r we write 1. So n factorial divided by n minus r means 1. R factorial means 1 factorial. Okay, and so therefore we expand this n factorial. So in this way n into n minus 1 factorial divided by n minus 1 factorial into 1 factorial. The value of 1 factorial is 1 here. So there is no need to write. And so therefore this n minus 1 factorial and n minus 1 factorial will cancel. It is only n by 1 it is n only, and so therefore n combination of the value of n combination of 1 is n here. So write here n into x raised to n minus 1, and so this is the derivative of f dash x, means our function is power function x raised to n. So the derivative of x raised to n is n into x raised to n minus 1, n into x raised to n minus 1, and so also we write also this derivative of f of x, means here f of x is here x raised to n, derivative of x raised to n function with respect to x is n into x raised to n minus 1. Hence we have to find the derivative of the power function x raised to n is n into x raised to n minus 1. For example, we may take here derivative of x raised to n means derivative of x raised to 2 here. It is a 2 into by using this formula 2 power, yes, x raised to n, x raised to n is 2 here, 2 into x raised to 2 minus 1, and so this 2 into x raised to 2 minus 1 is 1, so 2x, so derivative of x square is 2x. This is the example. We take any example. Derivative of x cube is just 3x square, derivative of x raised to 4, it is 4x cube. So in this way we have to find any derivative of power function by using this basic formula x raised to n. Now today we will stop here. Remaining derivative of standard function we will take next lecture. So today we will stop here.